Surveys are everywhere. Most of the participants in this CSCW conference have likely administered a survey. As researchers, all of us worry if the responses to our surveys are accurate. Inaccurate surveys can lead to a loss of generalization to our findings. This talk will show you how to design surveys that better reflect participants' true preferences. Often, decision makers deploy surveys to understand stakeholder preferences to help allocate limited resources. For example, a corporation may use surveys to inform product development priorities. A government agency may deploy a survey to better understand public opinion when developing a specific policy. Today, eliciting accurate self-reported survey responses remains challenging. The typical survey uses techniques developed almost a century ago. For example, consider the Likert scale survey. This figure shows an example question from Likert's 1932 paper. Below, we have reproduced the same question on Qualtrics. Might Likert be surprised that little has changed in the intervening time? Can we do better, we ask? With modern computer interfaces and their ability to make real-time calculations, can survey elicit more accurate responses? Ti-Chung and my co-first author Tiffany will introduce a survey based on quadratic voting that we shall refer to as QV. We will show through mechanical Turk experiments with two types of surveys, typical to our community, that QV-based surveys better align with individuals' true preferences than Likert scale survey. Assume that I own an ice cream shop, and I can produce a limited number of ice cream flavors to sell. Of course, I want to produce what my customers want. What should I do? Like many decision makers, when facing resource-constrained scenarios, I want to understand, first, how much people prefer each option, and second, how would people prioritize the option. I could use a ranking survey to ask customers how they rank the different flavors. However, ranking surveys cannot elicit how much more a participant values a flavor over the other. I could also deploy a rating survey, for instance, a Likert survey, to ask participants how they value each of the different flavors. Notice that in the Likert survey, customers assess each flavor independently and do not explicitly prioritize. Likert scale surveys are prone to extreme responding bias. For example, customers can rate all options as really like it. Quadratic voting, an idea made popular by Lally and Weil, is a promising alternative that appears to balance the rating and ranking-based survey instruments. In QV, voters have to pay quadratically to cast any number of votes across options within a given budget. QV straddles the mechanisms of rating and ranking, allowing multiple votes elicit preference strengths in a way ranking surveys cannot, while sharing the same budget and incurring a cost while voting forces voters to make trade-offs, which may lead to more rational prioritization than rating surveys. We will walk you through how QV works using the ice cream example. In this QV survey, it asks customers to express how much they like the different flavors. Each of them has 18 credits as their budget. Their votes have a quadratic cost. One participant, Tom, likes chocolate and vanilla but hates cookies and cream. He first casts 2 votes in favor of chocolate flavor, which would cost him 4 credits, then 3 votes against cookies and cream, costing another 9 credits. Now he has 5 credits left and need to make a trade-off in his next step. He can either cast an additional vote on chocolate, consuming all his remaining credits, or he can trade this additional vote for 2 votes in favor of vanilla, which costs 4 credits. Prior work on QV focuses mostly on theoretical proofs, with 2 empirical studies stating that QV and Likert yielded different outcomes. Yet, none of these work focused on empirically examining QV's ability to elicit people's true preferences in resource-constrained setting. So we wonder, can QV better elicit true preference?
In this study, we test our hypothesis that QV reflects people's true preferences more accurately than the Likert scale, which is the default of many surveys today. We examine the hypothesis in 2 scenarios. The first case is when choosing among k independent options under resource constraints. This is common in public policy decisions, such as deciding which projects to fund, given a limited budget. The second case is when choosing among k dependent options that jointly contribute to the same topic. This case is prevalent in HCI, for example, prioritizing different features of an interface that interact with each other under limited bandwidth or space. We conducted an experiment for each of the 2 scenarios. In the interest of time, we focus on our first experiment on choosing among k independent options in this talk. In this experiment, we also test if giving people a different budget of credits affects the survey accuracy. The first experiment has a stratified sample of 219 participants on mTurk. We designed a public policy survey about which of the 9 independent societal causes need more support. Participants either completed a 5-point Likert scale survey, or 2 of the 3 QV surveys with either a small, medium, or large budget of credits. We see 2 major differences in the results from the 2 surveying techniques. First, the distributions of liquor responses to each cause were often skewed towards the extremes, while QV responses were normally distributed. This may be because QV gives users more flexibility to express their extreme preferences as long as they're willing to make trade-offs. Second, liquor responses on the causes in red boxes have similar mediums and interquartile ranges. In QV, we can see apparent differences across those causes. QV results allow us to quickly rank the options and understand how much people prefer one to another. To understand participants' true preferences on the societal causes, we used a binding voluntary donation task on charities of the 9 causes with a lottery incentive. We asked them how much they would like to donate to any of the 9 charities and how much they would like to keep to themselves. Since they would want to maximize their bonus, they should donate more to Organization A than B only if they care more about the cause of Organization A. We are ready to compare participants' survey responses and donation amounts to see how closely the survey responses align with their true preferences. A good alignment means one only votes more or rates higher for option A than option B only if they are willing to donate more to option A than B. And the more they vote for option A than B, the more they are willing to donate to A than B. We used the cosine similarity angle between the donation amount and the votes and ratings in surveys to capture the degree of alignment. Using Bayesian modeling, we fitted a student t distribution for the mean angle of each of the 4 groups. On this axis, to the left means a smaller angle and a better alignment. QV with medium and large budgets are the 2 curves to the left. Their angles are significantly smaller than those of the liquor survey, the curve on the right. This offers strong support for our hypothesis that QV reflects true preferences significantly better. QV with a small budget was not significantly different from the liquor survey. Our second experiment studies the scenario of choosing among k dependent options that jointly contribute to the same topic in an HCI context. We arrive at the same conclusion that QV's responses align significantly closer to the true preferences than those from liquor. Please see our paper for more details. We have 2 theories on why QV with medium or large budgets elicits more accurate true preferences than the 5-point liquor scale. First, we believe that QV forces participants to make trade-offs. One of the participants mentioned feeling expensive when voting. Second, we think that QV allows more flexibility for participants to express their preferences since one liquor participant wishes to express an attitude between the given options.
This result doesn't mean that you should not use liquor at all. We advocate for the use of an alternative tool, QV, in certain scenarios, especially when you need to survey stakeholders' preferences to inform decisions about allocating limited resources. QV offers a signal that better reflects true, self-reported preferences. And if you want to understand simultaneously how people prioritize a set of options and how much more they prefer one to another, QV operationalizes this better compared to standalone ranking or rating surveys. We believe that our study is just a starting point for understanding and deploying this instrument to elicit more accurate preferences. In the future, we want to study respondents' mental model as they respond to QV surveys to understand better how QV works. It is also important to investigate how QV compares to other surveying methods and whether it works in different scenarios to discover when QV works. And lastly, we hope to design a helpful QV interface to support the QV survey process. For many decision makers, stakeholder surveys are critical to better understand stakeholders' preferences. A survey instrument that could elicit accurate responses from the stakeholders could yield better resource allocations from the decision makers, improving stakeholder welfare. Through careful experiments with 2 survey scenarios typical within the CSCW community, we have shown that quadratically constrained surveys better elicit an individual's true preferences. QV accomplishes this by encouraging respondents to deliberate among us preferences via accessible trade-offs among us the choices. We believe that our work can help inform the next survey that you plan to conduct. We would love it if you'd like to play with our code for QV, available open source on GitHub, and use it to deploy your own QV survey. We are also working on a QV platform to make QV-based surveys widely accessible, so that non-computer scientists can easily use this survey instrument. We hope this new instrument can empower you, when making your next decision. Thank you.